All right, guys, we can do this together. You are going to be interpreting, that means actually using slope-intercept form, and you're going to be doing that, you got it, with story problems. Come on, we can do this. Now, this is a story about inkjet and laser printers, but the key thing for each story as you're reading this, try to pick out what is your X, what is your input, what is your Y, what is your output. You need to know those things so that we can graph them. So you've got to read the story and think, what's the input and what's the output? Now, you can use a laser or inkjet printer to print an 18-page report. The laser printer prints 6 pages per minute, and the inkjet printer prints 4.5 pages per minute. We're going to write an equation to model each printer speed in pages p as a function of time in t minutes. That as a function of is extremely important. It's trying to tell you that the pages completely depends on the number of minutes that have been plugged into this problem. That means your pages p is your output, or your y, and your minutes is your input, or your x. So very nice to know. Now here's the great news. Every time the equations are actually going to be given to you. So take a look at the equations we have. This one is about the laser printer. P, which was our y, equals -6. Now that's how many pages we print per minute. And from the total pages we have, which is 18, we decrease by 6 pages per minute. That's where that's coming from. Same thing with the inkjet. Y equals -4.5 x plus 18. Now we're going to graph both equations on the same coordinate plane. Now you should know something about these graphs already. You already know that your y-intercept is at 18, so my graph is going to have to vertically go to 18, but look at my slope. My slope is negative, so it's going to go from 18 down. That means my highest number on my y-axis is 18. So it looks like I can actually count 1, 2, 3, 4, 5. Oh, look at that. Reached to 18. Now, on the other hand, I'm going to print 6 pages per minute and 4.5 pages per minute. That means that my slopes are -6/1. That means I'm going to drop a lot and not run up very much. My slope here is -4.5/1. Again, dropping a lot, not going very far. So let's graph the laser printer, and we'll graph that in red. Now my y-intercept is at 18, so I plot my point at 18. And now I go my slope. Down 6. Oh no, I don't have an x-axis. Let's kind of space this out a bit since I know that I'm jumping pretty far. I'm going to make that 1 and this 2, 3, 5, 6, 7, and I really think that's as far as we need to go for 18 pages. So when I go down 6, I actually need to jump over to where I have my marker for 1. If you follow my point down, that's where my 1 is. Well, then I'm going to go down a 6 and go over to my 2 pages, go down a 6 and over to my 3 pages. I have now hit my x-axis. So if this is my number of minutes, oh, that says minutes. No, it really does. Let's try that again. If this actually says minutes, and this is my number of pages, that means, follow my line, follow my line. At 0 minutes, I've printed 18 pages. At 1 minute, I've printed, I have 12 left. At 2 minutes, I have 6 left. And at 3 minutes, I have no left. So my laser printer finishes in 3 minutes. Let's check out my inkjet. Now my inkjet's going to be a little bit harder to graph because it's -4.5, but they both start at 18. Now let's practice this. I'm going to go down 1, 2, 3, 4, and a half. We know where half is, and then over 1. Now I'm going to do the same thing. Down 1, 2, 3, 4. Notice I stayed in the halves every time, and over a half, or down a half, and over 1. 1, 2, 3, 4.5 over 1. And here's 1. Notice I'm saying in the halves. 2, 3, 4 and 1/2 and over 1. So if I connect these dots, look at what happened. My inkjet printer took 4 minutes. So take a look. My question, how many minutes do you save by using the laser printer? You save 1 minute by using the laser printer. I use that x-intercept because that's the final how many pages I've printed. Let's take a look at this one. Violin teacher charges one-time sheet music fee of $20 for adults, but no fee for children. They charge per hour $20 for both children and adults. Now, charge per hour, guys, that's money per hour. There's our rate of change. Write a model for the cost C in terms of, that's another way to say as a function of lessons. That means our cost is our Y and our lessons are our X. Now, we're going to write the equation together here. Your cost for the adults, well, it's $20 per lesson, and N is the number of lessons. But remember, the adults also have to pay a cost of $20 for the one-time sheet music fee. Now, the children, their cost equals the $20 per lesson and nothing else. So when we go to graph these, notice my equations. Now, think about your graphs. Your M here is 20. Your B is 20. Now, your B is a big number, and we have a positive slope. So our graph is going to get higher than 20. So I'm going to be very strategic about how I pick these. Now, here, my graph these. My M is 20 over 1 again. My B here, is there anything added or subtracted? No. So your B is 0 because you can always add 0. So when you graph the adults, well, let's think about our units here. Gosh, I know I need to get to 20 and then go really high. Let's graph this by tens. 20, 30, 40, 50, 60. Notice if you change the label or the units on the graph, you need to write those new units every time. And yes, for right now, we are only using an L shape because we won't have negative money and we won't have negative time. Now on these ones, because the number of lessons can just keep getting bigger, I'm just going to count 1, 2, 3, 4 and go as far as I can. So this is our number of lessons, and this is our cost. All right, let's graph those adults. Those adults start at $20 for their cost, but then they go up 20 and over 1. Up 20 and over 1 lesson. 20 and over 1 lesson. And we have that line. Come on, you can draw this. All right. Now the children don't start anywhere. So they have 0 as their starting point. But then they go up 20 and over 1. Up 20 over 1. Up 20 over 1. Notice what's happening on this graph. Those two graphs are never, ever, ever going to intersect because look at their slopes. Their slopes are exactly the same. So these lines are parallel because our slopes are both 20. These lines are parallel. That means the difference for the cost of an adult and a student is always going to be $20. Look at that. At 5 lessons, there's the difference between the cost of an adult and a student, and that's a difference of $20 every time. Where does that difference of $20 come from? Well, remember that the adults had to pay this one-time fee that the students never did, and then they kept the slope the same from there. So the difference will always be $20. And that's pretty much what your homework is going to be. They might ask you, how much time do you save, like in this example, and they might tell you, how different is it from line to line? Well, we looked at 4 lessons, the difference in cost there. We looked at 5 lessons and the difference of cost there. So your assignment goes over that, and they will give you the equations. So good luck to you.